So here we go, Euler's method. So we're taking a derivative function and we're using that with the slope function to figure out the next y value. So the next y value is going to be my y of n plus 1. So y1 will be y0 plus my, in this case, 0.5 is my increment, and then 2x0, y0 is that. So now we're going to find out what y1 is. y0 is 2. 0.5, 2 times 2 plus y0. Oh, I did that wrong. 2 times 1, right? x0 is 1 and y0 is 2. So 2 and 2 is 4. 4 times 0.5 is 0.2. So this will be 2.2. Anybody disagree with that? Is that okay? All right. So now you do the next one. Oh, yeah, this is 4 times 0.5, yep. So this will be 2 plus 2 is 4. Thank you. All right. So now we're ready for the next one. So let's do another color here. X1 now is 0.5 from 1, so it'll be 1.5. Y1 is 4. H is still 0.5, and we're going to find Y2. That's what we want to find next. So using this formula, I like to write it first. You don't have to, but y2 equals y1 plus 0.5 2x1 plus y1. Okay, so y2 equals 4. 0.5 times 2 times 1.5 plus y1 is still 4. So help me out this time. This is going to be 3 plus 4 is 7. 3.5. Does that look right? 7.5? Okay. You try the next one. You try the next. All right. So now we have x2 is equal to 1.5. Add 0.5, you get to 2. And then you're going to have y2 is equal to 7.5. H is 0.5 still, and we want to find y3. Just for fun, you'd keep doing this. What would x3 be? 2.5. And then, did anybody figure out y3 yet? 13.25. And then H is still 0.5. And then y4 is what we're trying to find. Now, my question is, how many times do you do this? If you're going to x equal to 3, when do you stop? When do you stop? Do you stop at 3 or do you stop at x equal to 2.5? 2.5, because it'll bring you 0.5 to 3, and that's where you wanted to stop. So this is very important that you know when to stop. It's 1 H before x event. And I think that's the only tricky part of this. Formula is easy. It's probably even in there. All right, then how would you draw a slope field if you had to? I can't believe they'd ask it, but I have seen it on there. Yeah. So next, you have 2xy. So what you're going to need to do is to chart this out. So if both x and y are 0, what's the slope at 0? 0. How about at 0, 1? Well, now the slope is going to be 0 plus 1, right, which is 1. And then how about at, I'd rather use a different color here. How about at 0, 2? Well, that slope is going to be 2. 0, negative 1. 0, negative 2. Okay, now how about at 1, 0? So at x is 1, you're going to have a slope of 2 plus 0 is 2. And then this will be 4. And then at 1, 1, this will be 3. And you can kind of see pattern here at 1, negative 1 at 1, which is 2, plus negative 1, is going to be 1, and then it's going to be at 1, negative 2 will be 0. And so, you can kind of see the patterns taking hold. And you would just plot each one. That isn't hard, is it? Just remember, what's this? The slope. That's what you're finding. Next, L'Hopital's. So with L'Hopital's rule, we had 7 different indeterminate forms. Do you remember any of them? That's one, the most common that you would see. Gabby, are you okay? All right. Infinity over infinity, that's another one. What else? 0 to the infinity, yep. I know 1 to the infinity, and then this is where I forget them. It's infinity minus infinity, that's 1. You're right, 0 to the 0. Yep, and then the last one is infinity to the 0. Each one of these can be made into a 0 over 0 or an infinity over infinity. You have to determine one of those. By the way, write these down. You'll want to memorize these. I don't think they're in your packet, are they? And so what you do is you plug in first, and if they don't get one of those forms, you just say it's that limit. Like, what's 1 over infinity? 0. That's not an indeterminate form. You wouldn't use L'Hopital's on it. How about infinity over 0? Not an indeterminate form. Infinity over 0? No. No. Infinity over 0 is not, no. Another one that's, how about just infinity over 1? How about 5 over 0? None of those are indeterminate forms. So they have to be one of these 7. Okay, so what we do first is we put the values in. So here's an easy one. 4 times infinity squared minus 2 over 5 times infinity plus infinity squared. This is just infinity squared over infinity squared. Is that indeterminate form? Oh, this one's cubed. Oh, okay. So still is that an indeterminate form? It actually is, because yeah, you can simplify a little bit, but it's still infinity over infinity. So what? Well, but we would use a technique. We would use a technique that's separate from this, but you could use L'Hopital's rule for this. You could say this is infinity over infinity. Then you could say this is going to be 1 over, or 0 over 1.